Today we're going to talk about integration. In the last few videos we talked about differentiation, and we saw that differentiation is the rate of change of any specific graph. So if we have a graph or a function, in this case maybe a straight line function, and we get the derivative of that function, we actually say 3x, the derivative of 3x is 3, and the 3 is actually the rate of change of the graph, or in this case it's the gradient of the straight line. Today we're going to talk about integration. So integration is actually called, another word for integration is antiderivative. And as you can imagine, antiderivative is the inverse of differentiation. So if you want to take an answer of a differentiation and we get the antiderivative, we go back to the original function. So to go from here to here, we differentiate, and then to go back, we actually integrate. So integration is an antiderivative action. So if we integrate, we get the inverse of differentiation. So if we go back to getting the derivative of a function, let's say we've got a function, and the function is ax to the power of n. If we get the derivative, the steps that we'd use to get the derivative is actually multiply. So we multiply it by n. So it will be a n x, and then we subtract 1 from the, so we subtract 1 from the power. Okay, so if we do the derivative of a function, we are doing the exact opposite. So let's say we've got the derivative and we want to get the derivative of ax to the power of n with respect to x. What we're going to do is we're going to do the inverse operation. So we did multiply, then the subtract. Now we go in the opposite direction, and now we're going to add 1 instead of subtracting 1, and we're going to divide by the exponent. Okay, so let's start. So we'll say in this case we're going to add 1, so it's going to be n plus 1, and we're going to divide by the new power, in this case n plus 1, and we're going to say we need some constant to add to this. Okay, so let's take the example of a function that we're going to do. So let's say we're going to take 5x to the power of 3, and we're going to get the derivative of this function with regards to in respect to x. We're going to say it's going to be 5x to the power of 3 plus 1, and we're going to divide by 3 plus 1 at the bottom, plus a constant. So that will be 5x to the power of 4 divided by 4 plus a constant. Okay, so why the constant? So let's go back and we'll take a function. Let's say we've got a function again, and it's going to be 5x squared minus 1. If we get the derivative of this function, we will say we multiply 2 by 5 gives you 10, and we subtract from 2 and we get 1, and the answer is 10x. And now let's take another function, 5x squared plus 6. Again, let's get the derivative. It's going to be 5 times 2, which is 10x, and plus 6, that's 6 to the power of 0. We multiply the 0 with the 6, so it gives you 0. times x minus 1. So 6 times 0 is always 0, multiplied by whatever, it's always going to be 0. So this, if you get the derivative of a constant, we always get 0. So we can say the derivative of a constant is always equal to 0. Okay, so you can see in this case we had 1, and in this case we had 6, and the answer of both of these is just x to the power of 1. So let's go back to the derivative integral of this 10x. If we get the derivative of the 10x, we say 10 to the power of x. There's a 1 there, so we're going to see 1 plus 1, it gives you 2. Divide by 2 plus c, and then we get to the original function, which is 5x squared. But you can see that's the 5x squared, but we don't know what the constant is. So it might have been minus 1, might have been 6, or something else. And that's why we always say plus c for the constant. And this is how we do the derivative of functions. So remember, the same rules apply. We can have multiple functions, and we can also have algebraic equations. Remember, in these cases, just like the derivative, we always have to put this in exponential form. So this is going to be x to the power of minus 2 dx. And now we've got multiple terms. We do the integral of each of the terms separately. So we're going to say x half plus 1 is actually half plus 2 over 2. That will give you 3 over 2. Divided by 3 over 2, or multiplied by 2 over 3. Next term is going to be x minus 2 plus 1. It will be x minus 1, and we divide by minus 1. And again, we do a plus c. So the final answer might be, might write this at 2 over 3 x to the power of 3 over 2 minus x to the power of minus 1 plus c. Or if you like, 1 over x plus c. And that's how we get the indefinite integral. So this is called indefinite integral because we don't have any ranges here. So if we look, remember we talked about differentiation. Differentiation is getting the rate of change of a function. Integrals, if you look at a function, integral of a function is actually the area under the graph and between the graph and x. So if we look at derivatives, that's always the rate of change. And integrals are always the area of a graph. Okay. That's it for today.